Hello guys, this is Dr. Komal, CTBS surgeon. Our new website, CARDIOBEAT.IN, was started with a motto of sharing our knowledge on heart and diseases through YouTube videos. Also, we own our website, CARDIOBEAT.IN, whose link will be shared in the description, where you can get your PPT presentations as well as notes. So do follow us, like, share, and subscribe our YouTube channel. So today's subtopic under embryology of heart, we will be discussing upon the development of sinus venosus. For development of sinus venosus, we will try to recollect one of the picture from our fourth video, cardiac looping. So this picture depicts the formation of heart tube from two endothelial lined heart tube into a single heart tube where the caudal part is unattached, forming asymmetrical dilatation leading to the formation of various structure within a single cardiac tube, namely the bulbus cordus, primitive ventricle, primitive atria, sinus venosus with its two horns at its caudal end, namely the right and the left sinus horns. So, our focus of today's session will be on primitive atria, sinus venosus, and the two horns of the sinus venosus. As we all know, this is the venous end, which is going to receive tributaries at various levels of the embryo, and it's going to pump the blood towards the cranial end. So, what are the tributaries of sinus venosus? We have three paired veins on either side. So, the first paired veins are the right and left umbilical veins. The second paired veins are the right and left vitelline vein. And the third paired veins are the right and left common cardinal vein. So these are the tributaries of the sinus venosus. So where do they drain? Which part of the embryo these paired veins drain? For this, we will try and recollect one more diagram from our third video of formation of heart tube, where we have a larger picture of the embryo inside the amniotic cavity with its mesoderm, endoderm, yolk sac, and the connective stalk. The connective stalk is nothing but it is the future umbilical cord which is getting attached to the chorion. In other words, the placenta, which is formed from the cytotrophoblast and syncytiotrophoblast, which is getting attached to the maternal endometrium. So, the three paired veins or the tributaries of the sinus venosus, namely the umbilical vein, vitelline vein, and common cardinal vein, are going to drain various parts of the embryo. So, the umbilical vein is going to drain the chorion. Vitelline vein is going to drain the yolk sac, and the common cardinal vein is going to drain the body of embryo. We will try and put this entire vein and the venous system into the embryo. So for this, let me draw the embryo first. So we have the embryo with its heart tube with sinus horns. Now it is getting tributaries from various ends. The first tributary is from the chorion, in other words, the placenta. So namely the umbilical vein. And then we have the vitelline vein, which is draining the yolk sac. And then we have the common cardinal vein draining the body of the embryo. So the common cardinal vein, in other words, it is getting its tributaries from two other veins, the anterior cardinal vein and the posterior cardinal vein, which combine to form the common cardinal vein. Okay, let me put all three pad veins or the tributaries of sinus venosus in this picture. So we have the primitive atrium, we have the sinus venosus. This is the opening of the two horns of the sinus venosus, namely the right and the left sinus horn. Here we have the opening of the common cardinal vein. Here we have the right anterior cardinal vein and right posterior cardinal vein, both combining or joining to form the right common cardinal vein. Here we have what is called as right umbilical vein, and we have the right vitelline vein. Similarly, on the left side, we have the common cardinal vein on the left side with its counterpart. On the left, we have the left anterior cardinal vein and left posterior cardinal vein. Here we have the opening of the left umbilical vein, and we have the opening of the left vitelline vein. So this is how we have the picture of the sinus venosus with its two horns with three tributaries on either side opening into the chamber. So in the following picture, I've drawn the entire heart tube with its various asymmetrical dilatation starting from the cranial truncus arteriosus to the caudal sinus venosus with its two right and left horns, as well as the three pad tributaries on either side. We know that by the process of cardiac looping, the straight cardiac tube is going to undergo transformation, thereby the caudal end moves cranially as well as dorsally, whereas the cranial end is going to move caudally and ventrally, in other words, anteriorly. So in this picture of heart tube, the first picture, the heart tube with its various dilatation at its various end, it's still in the straight line. The second picture, it has started the looping process. And the third picture, you can see there is difference between the second and the third picture, where the more cranial end, this more cranial end, the ventricular end has become, it has started coming down or caudally, and it is more anterior. Whereas this atrial end, which is more caudal, has started moving dorsally and it has come more cranially. Right. Now sharpen your imagination so that the straight tube with its venous tributaries at its caudal end, after looping, how does it look like? You will be getting a picture exactly like this. So the ventricular end has shifted more caudally and anteriorly. Behind that you have the primitive atria. Behind that you have the sinus venosus and its tributaries. This is how exactly post-cardiac looping from anterior to the posterior end you have the structures placed. Now certain changes will happen with time with the tributaries of sinus venosus. So what are those changes? So for knowing the changes that are happening in the sinus venosus, just like the way we drew this picture, just focusing on the primitive atrium and sinus venosus with its three tributaries on either hand, but this picture we drew when the heart tube was in straight line. So similarly, we will draw the sinus venosus as well as its tributaries post cardiac looping. So it is this picture I was talking about. So in the first picture, you are just standing behind or you are posteriorly visualizing the primitive atria and sinus venosus. So you're standing behind posteriorly, or in other words, dorsally, you're visualizing. So what you are having, more anteriorly, you are having primitive atria. Just behind that, you have the sinus venosus with its two horn. This is the left horn and this is the right horn. Here you have the vitelline vein, umbilical vein. Then you have the anterior cardinal vein, posterior cardinal vein, and common cardinal vein. Similarly, on the left side you have. So the second picture we have here is a picture. This is the side view of the picture. Take for instance the right side you're standing and visualizing. So on extreme anteriorly on the right you have the primitive atria. Just behind that primitive atria, you have the sinus venosus and the two opening of the left horn and the right horn. Here we have the anterior cardinal, posterior cardinal opening into the common cardinal. Here we have the vitelline vein, right vitelline vein and the right umbilical vein. So we have the two views. One from the dorsally or posteriorly you are visualizing, and the second view is the side view. Changes that are happening to the tributaries. So for this we will write the veins as right and the left. So here we have the right umbilical vein, right vitelline vein and right common cardinal vein. Left umbilical vein, left vitelline vein and left common cardinal vein. So during the 5th week of intrauterine life, on the right side, right umbilical vein disappears. Similarly, on the left side, the left vitelline vein disappears during the 5th week. During the 10th week of intrauterine life, the left-sided common cardinal vein disappears. So on the left side, because of these changes, only the umbilical vein is left. So as we all know, in the umbilical cord, the only vein that is left umbilical vein. Similarly, on the right side, only two structures or two veins or the tributaries are left out. One is the right vitelline vein and the right common cardinal vein. So the left side of venous system is at disadvantage. At this juncture, I would like to add one point. So in intrauterine life, the flow of blood is from left side to right side. So because of this, left side is at disadvantage, and because more blood is flowing towards the right side and right side is receiving more amount of blood, so the vessels on the right side grows more in comparison to the left side. So how this happens, we will study in the upcoming class, but for this moment, just to understand, since the flow of blood is towards the right sided vessel enormously grows in size as compared to the left side. So if we apply this rule of blood flowing from the left side to the right side to the left umbilical vein, then somehow left umbilical vein should also at later period drain into the right sinus horn. How this happens, we will study in upcoming classes. But for now, just remember, on the left side, there is no tributaries are going to drain into the left sinus horn. So the left sinus horn is at disadvantage. So having said that, we will try and remove all the tributaries of the left sinus horn, namely the cardinal tributaries, the umbilical vein, and then you have the vitelline vein. I will try and remove the left sinus horn. So we have the sinus venosus with just the right sinus horn. How simple is that? But it is not so. Why? Because still the left sinus horn is persisting. How? This is mainly because the left sinus horn is not only receiving the tributaries as told earlier, they are also receiving a small contribution from the heart itself, namely the oblique vein of left atrium as well as the coronary sinus. So because of this contribution, the left sinus horn is still persisting, but it is smaller in size as compared to the right sinus horn. So we will draw the left oblique or the oblique vein of left atrium as well as the tributary from the coronary sinus. So still the left sinus horn is persisting. Till now we have studied about the changes that are happening to the tributaries of sinus venosus. So we have seen the sinus venosus from behind, posterior view. Now we will try and understand what are the changes that are happening within the sinus venosus itself. So for this, we'll move to this picture, the earlier picture. So this is the sinus venosus, right? And here we have the primitive atrium. So between the sinus venosus and the primitive atrium, there is a valve situated. the sinus valve. So here also we will draw from the side view post looping. We have the sinus valve in between the primitive atria and the sinus venosus. So understanding changes within sinus venosus. So it's not about the tributaries, but changes that are happening within the sinus venosus, mainly the sinus valve. So for this, I have tried to draw this picture. The purpose of drawing this square-shaped picture is that I'm really poor at drawing the 3D picture. So for me, it is very easy to depict the square-shaped 3D picture rather than a spherical 3D picture. So please try to take this square-shaped 3D picture as the primitive atrium. Okay, primitive atrium with this roof. This is the left wall of the atrium. So roof and left wall we are seeing from the outer side. Here we have the inner side from within the primitive atrium. We are seeing the right wall as well as the floor of the primitive atrium. So behind this, so this is actually the anterior view. So we are watching the primitive atrium from its anterior end. So behind the primitive atrium, as we all know, we have what is called as the sinus venosus. This is sinus venosus and this is primitive atrium, right? So we are looking the primitive atria from the anterior side. So this thing is nothing but it is the opening of the sinus venosus into the primitive atria. So this opening is in fact guarded by two valves. So they are guarded by two valves like this. So this is one valve and this is another valve. Right. Let me draw this opening alone here. So I'm drawing just the opening or the junction between the sinus venosus with that of the primitive atria. So we have the two valves like this. Now what they say is that during the initial period, this valve is horizontally placed. But after some time, the valve becomes vertically oriented. So this is how a vertically oriented sinus valve looks like. So the sinus valve which is guarding the sinus venosus as well as the atrial end has two valves, the right and the left sinus valve. With continuous changes that are happening during the intrauterine life, the dorsocranial end of both the right and the left sinus valve, they merge with each other. So this dorsocranial end is going to merge with each other. Right. So this end is now termed as the septum spurium. So with time, the left sinus valve loses its importance and the right sinus valve becomes the predominant valve. So here you have the left sinus valve and here you have the right sinus valve like this. So at the same time as the changes are happening with the sinus valve, the changes are also happening with the primitive atria. The change that is happening is the formation of atrial septum from the roof. So the septum starts forming from the roof, dividing the primitive atria. So the septum spurium. So this is the septum spurium. And then we have the left sinus valve. So this is left valve. So this both septum spurium and left valve now gets attached to the wall of the atrial septum. So the atrial septum is now started to form. So with this, the septum spurium gets attached and the left sinus valve gets attached. We now know the fate of left sinus valve and septum spurium. They both get attached to the atrial septum. So what is the fate of right sinus valve? Two changes are happening. The first change that is happening is the sinus venosus as a chamber is getting absorbed into the primitive atria. Or in other words, since the primitive atria has started its septation process, now the sinus venosus chamber is getting absorbed with its right sinus horn into the right atrium. Second change that is happening, since the chamber of sinus venosus is getting absorbed, now the right sinus horn is direct in connection with the right sinus valve of sinus venosus. Because of this, the right sinus valve enlarges. So take this picture into consideration. So in this picture, we are seeing the anterior view of primitive atrium with sinus venosus at its posterior end. So here we have the right sinus horn entering into the sinus venosus with its anterior cardinal vein, posterior cardinal vein, common cardinal vein, and then here you have the umbilical and the vitelline vein. On the left horn, it is almost negligible because every other tributaries has regressed except for some contribution from the sinus venosus. Some contribution from the sinus venosus and the oblique vein of the left atrium. Right. As sinus venosus is getting absorbed into the atrium, changes also happen within the right-sided tributaries. So this change results in the formation of SVC and IVC. So how do these right-sided tributaries, namely the cardinal system as well as the umbilical and the vitelline venous system, develop into the SVC and IVC will be taught in the upcoming classes. But for now, we will just remember that these tributaries ultimately, or in other words, simultaneously, get converted into the larger picture, namely the SVC and IVC. So now we will remove sinus venosus completely out of picture because it is going to get absorbed into the right atrium. So the individual tributaries are also going to form SVC as well as IVC. So their openings are going to be somewhere directly into the right sinus wall. So this is the opening across the SVC and opening of the IVC somewhere here. And somewhere this coronary sinus is also getting opened in the right sided valve. So this also we will remove. So now consider just the opening of the sinus valve. So this picture already it has turned into septum spurium, and this is the regressed left valve, and they are going to get attached to the atrial septum, the growing atrial septum. So what we will do is that we will draw another picture taking the septum spurium as well as the left valve out of picture. We will draw only the right sided valve. So this right sided valve is now receiving SVC, IVC as well as coronary sinus. So because it is receiving more and more blood, the valve enlarges. So it starts enlarging like this. The wall of the right valve enlarges. So here at the top end is the SVC. Here you have the IVC. Here you have the coronary sinus. Because of more enlargement of the SVC, IVC and coronary sinus, the right sinus valve moves further far away and enlarges and gets closer and closer to the right atrial wall. And at one time, it gets incorporated into the right atrial wall and gets disintegrated at its lower end. So the remnant of the right sinus valve in adult life are seen at three places. One, it is getting attached to the right atrial wall, and this demarcation is what is called as crista terminalis, and it guards the entry of IVC as the eustachian valve and coronary sinus as the Thebetian valve. We have reached the end of today's class. For completion, let me draw a cut section of right atrium in the adult heart. Here we have a picture of adult heart where the right atrium has been opened up on its anterior part. So this margin is the crista terminalis, which denotes the right sinus valve getting incorporated into the right atrial wall. So right sinus valve getting incorporated into right atrial wall, particularly forming the smooth walled right atrium. And crista terminalis denotes the margin of separation across the smooth walled right atrium as well as rough side of right atrium, denoting the pectinate muscle. Here we have the IVC and the remnant of right sinus valve, namely the eustachian valve. Here we have the coronary sinus and the remnant of sinus valve, namely the Thebetian valve. This is the SVC. This part is the tricuspid valve. So with this we have completed our fifth subtopic, sinus venosus development. Thank you.